Welcome to SSH, MSF, and TOR equals anonymous remote shells. My name is Catatonic. You can find me on Twitter at CATATONICPRIME. Things that I like whiskey hacking, crypto-enabled privacy, sometimes all at the same time, and some boilerplate disclaimer stuff if I use the F word or the S word or the C word or the P word or the M word or the N word or, whatever. I don't know. They're all my own, ignore it. My employers, we're not talking about them. I'm not doing anything too crazy. And they don't have no part of it anyway. So insert whatever boilerplate you want for disclaimer. Why am I here? I'll let Joey explain.
I'm in this computer, right? So I'm looking around, throwing commands at it. I don't know where it is or what it does or anything. It's like a choice. It's just beautiful, okay? Like 4 hours of just messing around in there. Finally, figure out that it's a bank. Right? Okay. So it's a bank. So, this morning, look at the paper. Some cash machine in like Bumsville, Idaho, spits out $700 into the middle of the street.
That's kind of cool.
That was me. I did that.
You did this from your house.
What are you, stoned or stupid?
You don't hack back across state lines from your house. You get nailed by the FBI. Where are your brains? In your ass? Don't you know anything?
Stupid, man. It's university. Stupid.
You guys always stick up north and you never tell me anything.
All right, so I'm here to tell you some things. So I've spun up a wireless access point. If you want to play along, the SSID is Catatonic. The password is Catatonic 2017, all lowercase. If you have an attack VM or something, if you can spin this up, just kick into Metasploit. I don't expect you to have all the tools to play along the entire time, but if you want to mess around, you can. I'll have this available if anybody wants to play with this afterwards. I can spin it all up because it does take a little while. I'm going to cruise through it as fast as I possibly can because it can take a while to kind of get all the pieces and really stick them together. But yeah, we're going to do a lot of live demos. I'm going to be showing kind of each of the steps and describing each of the things as we go through. I hope that is illustrative. But also, if you do join, please don't be an asshole. Don't take down my network. If you're sitting outside, please don't start de-authing my Wi-Fi's or your Wi-Fi's, etc. Don't crash my VMs. I mean, if you get in, you can do some stuff. That's great. Just try to keep it up and available. You can do whatever you want. Don't run automated tools. I gave a workshop on the same subject a few weeks ago at CactusCon, and yeah, the automated tools, when you have 100 hackers sitting there and they're all connected at the same time, and 5 of them are saying, hey, you know what? Let's just run Arachne, Nikto, WP scan, everything. Let's just throw the kitchen sink at it. Stuff starts to go down pretty fast. I mean, it's all running on my laptop. So if you do pop in, the target scope, there's 2 servers on 192.168.0.10. That's a web server. It's also www.encipha.red. So enciphered, but with a period before the red. And 192.168.0.79. That's just an SSH box that's hanging out there. And then I have about 10 IPs in the 10 space, which are also in scope, but you won't be able to do very much there, I promise. If you can, well, I guess that's cool too. Just don't take down the services running there. And the last one is the 172 space. If you're joining the network, this is where your neighbors will be. I can't authorize you to hack your neighbors. You can ask them if they want to let you hack them, but I can't do that, so I'm not going to. So just stay away from those. That'd be great. Thanks. Bye. All right. So what is Metasploit or MSF? MSF is the Metasploit framework. Just quick note: anagrams might get you unemployed. If anybody was following DEF CON and the debacle following that with the meat pistol incident. And yeah, right. I mean, it's just a matter of whether or not you want to actually generate your resume. So I'm not gonna go I'm not gonna try to make up anything fancy, but that's a thing about Metasploit. It's an awesome tool though. It's a repository of known working exploits that have been really well flushed out by security professionals, much like many people in here. But one of the really great things about it is the framework aspect of it. It's actually super flexible, and what makes it super flexible is that they've sort of disconnected how payloads interact with exploits and how handling of those payloads to create sessions and manage those sessions so that you can keep utilizing a resource once you've compromised it is really incredible. So you can take an arbitrary payload and inject it into many different types of exploits. And even if the payload's too big, it'll do things like help manage the staging of the payload. So maybe the exploit delivers a very small payload. That payload connects back to a stager, which delivers a larger payload, and then that connects back to get a even longer running session, so that you can then deliver new payloads to the target machine or a remote machine inside of a network, or additional exploits. So this would be all of your pivoting and post-exploitation tools. It also supports some automation tools for scripting. So there's two commands, make RC command and the resource command. I'm going to be using these. When you log in, you can just like do a bunch of stuff and then hit make RC, and it'll create a file that does all of the things that you just did. So it just makes a copy of your same current active session. And what all of this comes down to is we get to hack like super fast. I'm going to use an exploit called the exploit multi-handler. This helps when you're receiving many sessions. So if you have lots of hosts that you're attempting to compromise, you can collect as many sessions from all of those hosts as you can. If you've never used Metasploit, I think this is one of the most important concepts to get early on, if you can, to focus on how to use the multi-handler, because it'll save you so much time in the long run. But a lot of times you can also just one-shot Metasploit. You pop it up, you throw an exploit at a random thing, you don't set up a multi-handler or any of that jazz, and you just get one cell back and you go, yay, I did it, I hacked the machine. In this case, I'm going to be using the PHP Interpreter reverse TCP payload. So I'm going to be hacking a web server, and it's going to connect back to me. And Interpreter is part of the session handling set that it does, and it's just a really phenomenal pivot and post-exploitation tool. It is the thing that helps you deliver new exploits into the system after the fact, to do your privilege escalation, to scan the internal network, to exploit an additional host further into the network. So what's this look like? Let's give it a try. It's 4 letters. Anybody want to guess what this password is? Oh, I got to set up one more thing too. I got to turn it on. All right. So we pop in. Oh, that's super tiny. I'll make that big. Heyo. How's that? Everybody like that? That's nice, right? Yeah, it's good. It's good on the eyes. So the command to load Metasploit is MSF console. Once it loads, you are presented with this prompt. And the first thing, like I said, I like to set up a multi-handler. So I'm going to go ahead and do that. I'm going to make this slightly smaller because I'm pretty sure this one fits. Yeah. So maybe even slightly smaller. Is that still okay? Right there? Everybody can still see that in the back? Everybody good? Okay, great. So I'm going to use this multi-handler. So I say, hey, I want to use this exploit multi-handler. Interesting attribute of this is I want to turn off its exit on session. So when it receives a session, I don't want it to immediately bail out. And I'm going to set it up to handle PHP Interpreter reverse TCP shells, just like I said I would. Now, I also want to bind it to a local host. This is going to be the host that receives sessions, and I'm going to bind it to all interfaces. So that's what the 0.0.0.0 meta IP does. It's just like all interfaces or no interfaces, sort of undefined. And I'm going to go ahead and listen in on 31337, the best port, and I run this exploit with this -j. This means run it in the background. And we can see that, hey, it's running in the background as job 0. I configure a few other options. This is just for expediency. I set the local host to the loopback device, and I change the local port back to the default port of 4444, and I run that as a job as well. In the end, this leads to 2 jobs running, both handlers, multi-handlers running reverse TCP, Interpreter, PHP, shell things, one listening on the external interface and one listening on the internal interface. once I have done this, and I'm just going to use the external one for right now. Once I have done this, I can run my exploit. This has just configured it. I'm just going to walk everything through. It's all live demos today, right? It's going to be nice and fun. So I know that I'm looking at a WordPress page. It is vulnerable to an unauthenticated upload vulnerability. This is contrived, of course, but you can do this sort of process with lots of things out there. So because I have set up my own handler, I'm going to disable the payload handler by setting disable payload handler to true. I'm going to set up my payload to be the same reverse TCP interpreter shell, and I'm going to use that 31337. I'm going to use that I just got another one. I'm going to use that 31337 port, which is the one that's listening on that external interface. Then I've got some some Ruby code that just helps me do this faster, which sets the local host to my external IP. And I set my remote host to be my target website, in this case, www.incypha.red. And I set the remote port to 443 because I'm running SSL on that server. So I also need to turn on SSL, say, yeah, we're going to use that for true. And I, after having already done my recon sometime prior, know that this is where the vulnerable page is. And then I always like to show options just so that I have a good idea of what all the options are, and I can see all the options I have set. And once I'm ready, I should be able to just run exploit, and we get our session back. So in this case, the exploit runs, and it turns on the vulnerable code, it prepares the payload, it uploads the payload, and then it hits the web server again to execute the payload. Once that payload executes, it calls back to my machine and says, hey, what am I supposed to do now? And my machine says, well, let's just keep the socket open, and we're going to keep talking. And we can see that I've received a connection on my external interface, and it's coming from my web server, which is the 10 host on the 192 network. Also, there's a nice little tip that, hey, there might be a file hanging out there when you get in that you might want to clean up so that somebody doesn't notice, per se. So this is what a interpreter session looks like. Nothing particularly special. You can run commands like ls. So this is everybody in the workshop who did not take the advice of removing their shells when they uploaded them, even though it said, hey, you might want to remove this shell. People just said, meh, and left them there, which is pretty interesting. I still haven't gone and checked out these files. They're a little bit different, a little bit larger. I'm curious if people were experimenting with other payloads. I hope so. It sounds fun. But once you're in here, I'm going to remove mine. I like to take the advice. Once you're in here, I want to look at, we'll just drop the session there. All right, so that's the idea of running. You exploit stuff super fast. A lot of people have probably already seen this, or you can check it out on YouTube. Everybody talks about how to exploit with exploit. So, hack from your house, right? You get nailed by the FBI. Let's do a quick analysis. Now that I have this session open in this shell, I'm going to look at the current active TCP connections, and we can see the connection coming in from my house to the web server on port 443. Does anybody think that a connection to a web server on a web port is weird? No, nobody's freaking out about that, right? All right, but from the web server, I have a connection going back out to my house on port 31337. Does anybody think that's weird? Yeah, we got one. Yeah, okay, so, all right, cool. Yeah, great. 3 people think it's weird. The rest of us are like, that happens all the time. Sorry? Yeah. Oh, yeah, totally. It's just Russians and the Chinese. Yeah, for sure. North Korea. All right, so that's weird, right? You end up with this. You end up with these connections coming back to your house, and the blue team they look at this and they go, oh hey, yeah, that's really bad. We should probably do something about that. And maybe it's within the local United States. If you work here, maybe it's worth sending somebody out there just to check, just to say hi, make a presence known, and maybe that's enough to prevent it from happening in the future, or maybe not, or whatever. I mean, it's to their discretion how far they want to pursue. So the way that you can help prevent your home IP ending up and the blue team calling the feds and sending them to kick in your door is you can do something like get an SSH Jump Box. This is approximately equivalent to getting a VPN if you're using PIA or whatever you want. And what the SSH Jump Box is going to do is it's going to forward connections from your host or from your SSH server to remote host or the vice versa. So it can take connections in and out, and it's a feature called SSH port forwarding that does this. Where do you get an SSH Jump Box, I hear you ask? Well, I suggest that you bring your own. If you're doing an authorized pen test, this is a really great way. You can just get any box in Azure, AWS, etc. A really great feature of this is there's a feature in SSH called gateway ports. And when you have root on the box, for instance, when you bring your own, you can turn this gateway ports feature on. It's off by default. And what gateway ports allows is for that SSH server to receive an incoming connections on its external interface. If this is turned off, it can only bind to the loopback, so it won't be able to receive connections on its external interface. So this is a great way to just like slap something out there and get your shells back really easy and put it in the report that, hey, I'll give you everything on the SSH Jump Box, and you can analyze it for your blue team analysis after the fact, and maybe you can help make some informed decisions from there. Or my personal favorite, I prefer this method quite a bit more. Instead of bringing your own, how about you compromise something in your target scope, like maybe some IoT or another web server. Maybe on the web server, there's a file disclosure bug that lets you leak an SSH key that gains you SSH access to the web server or to any other host, an admin's workstation, et cetera, et cetera, et cetera. I just saw on Threat Post, I think it was 2, maybe 3 days ago, that they've noticed a significant uptick in people scanning for SSH keys, IDRSA, IDDSA, and Git repositories, right? We have credentials all over the place, and SSH keys are really awesome because they don't expire. So if you get one, they can stay good for a really long period of time. And as long as you're not running around telling everybody that you have them, then they might stay good for effectively ever and on lots of different types of devices. So IoT is a really awesome place to look for this because, as we know, they don't get patches to begin with. And a guy, Elvis Collado, did a really great talk last year at CactusCon, B-Sides, GurCon, and DEF CON on reversing and exploiting embedded devices. He talks about using binwalk to pull firmwares apart and go explore their file systems. And I've noticed that when I do that, I tend to find SSH keys or default passwords or users that aren't in other documentation that also have default passwords. So maybe you can update the root password, but you can't update the password for the backup user. The downside to compromising your own when they update the root password but not the backup user password, the backup user doesn't necessarily have root access, so you can't turn on the gateway ports, which means you can't bind to those external interfaces, which almost cripples it for this. There's ways around it, which we can talk about later if we have time. So this is a diagram. I drew this. I hope you guys like it. I put the colors in. I worked really hard on it. I drew it with my finger on my tablet. It took me a long time. And this is what an SSH port forwarding situation looks like. So in this case, we're going to do what's called an SSH local port forward. This is where you configure your SSH client to build a tunnel to a server. That's the little green tunnel in the middle that goes through the internet. When it builds that tunnel, the client is going to accept incoming connections on an internal interface or external interface, in this case 172.16.42.100 on port 8080. And whenever a nearby host that can reach that port, that IP port combination, says, hey, I want to connect to you, it's going to take that connection, shove it through the SSH tunnel, and it's going to pop out at the SSH server, where that SSH tunnel has instructed the SSH server to take those incoming connections and just pass them on to a far away host. This could be the SSH server, or it could be a further away host. Something else on the network from the perspective of the SSH server or the far host. So the far host sees connections coming in from the SSH server. That's what its visibility looks like. And this is the local forward. The other option is to do a remote forward. Looks almost exactly the same, except backwards. You build the same SSH tunnel. You go through the internet. Your client connects to the SSH server and instructs the SSH server, hey, when you receive a connection, I want you to take that connection and send it back to me, and I'm going to forward it to a nearby host, which could be the client itself or some other nearby host from the perspective of the client, something that it can reach. And this is the one that we're going to use right now. So phoning anonymously, in quotes. And also best gifts, man. So I'm just going to reuse the exact same exploit with some minor modifications. So I've loaded my resource so I can walk through it, right? Makes it a little bit easier. We're using the exact same exploit. We're disabling the payload handler just like we did last time. We're using the same payload, only we're going to change our L port to 8080, which my machine isn't listening on. And then we're going to set the local host to be the IP of another host on the corporate network or somewhere out on the internet, in this case 192.168.0.79. My machine's on the 172 network. The 192s are the victims, and the 10s will come in later. We're still targeting the exact same stuff. It's all exactly the same. The real difference is the local port and the local host have now changed. I just need to do one more thing to get ready for this. Is that good? So I'm going to SSH into the remote host, and I'm going to set up this remote port forward to take connections coming in on port 8080 and to send them back to me over the SSH tunnel, and I am going to forward them to 127.0.0.1 on port 444. And this is going to be for the user on the pivot machine, which is pivot.encipher.red. The user is pivot. Password is pivot me. And now we have an SSH session open. I'm going to run the exploit. And we see the same sort of process occur. We see, hey, we turn on the vulnerable code. We send we build up a payload. We send it over to the server. We execute the payload. And then it connects back to us. Only it didn't connect back to us. It connected back to the pivot.enciphered machine. Pivot.enciphered sent it back to us over the SSH tunnel. We received it, and we sent it to our loopback device on port 4444. So what we see is, hey, we received a connection from ourselves to ourselves. It's just us. So we can interact with the session. We can clean up our shell just like we should. We can drop into a shell. We're back on the server. We do more analysis. So what does this look like, right? It's not quite as straightforward as the usual situation, right? Is we have multiple connections instead of just the one. We have the connection from the web server to our enciphered box or the pivot box. So that's weird. That might freak out the blue team a little bit. It's on port 8080, so maybe it doesn't freak them out too much. If this machine were on the internal network, so they're monitoring the web server, but not the pivot machine, but it's on the same internal network, like it's IoT, one might believe that, hey, that's just a normal connection. It's doing reporting. It's collecting statistics for something. It's doing whatever. It's getting updates. It's sending updates. It could be doing anything. The only weird part is that we still have our house connection connected. Well, that's not weird. Except we look again, and it's already been like 60 seconds, and it's still there, still running. And if you have even the slightest inkling that this might not be right, you might log into the SSH server or the web server and start looking at the process list and see, hey, there's a process that's been running for 4 hours, and it's just hanging out there. That's not normal. So you might start to investigate. And then you might start to investigate this. Also, this is going to show up in the access logs. You're going to have your home IP in the access logs. The access logs are going to say, yeah, we executed this script that looks like a interpreter session. The file's not there. You missed it, but we definitely ran it. And they didn't get to root, so they couldn't clear up the logs. Or you ship off to Splunk or Elk or something like that. So even if they got to root and cleared the logs locally, they couldn't clear the offsite logs. So analysis is just, hey, yeah, maybe we should go look at this host. But it did not connect back to itself. So does that describe a different type of intent? Or is it just, oh, hey, yeah, machines get compromised on the internet every day. It's part of a botnet. It's just participating, which more or less is exactly what we're trying to build out here, right? So yeah, those are the questions I can ask. This is a little bit different. All right, so TOR, the onion router. This is a privacy enhancing technology. And privacy enhancing technologies, there's lots of different types of them. And there's networks, there's browsers, there's even entire privacy suites such as Tails. So in this case, we're talking about the TOR network. We're going to use the TOR network. The browser is the TOR browser. That's the one that most people are familiar with. This is a browser. It's based off of Firefox. It's specifically configured to connect to the TOR network and help provide additional privacy to TOR users. Tails, very similar. It's an entire privacy suite where it ships with the TOR browser. It primarily connects to the TOR network. Usually, many people use it to also connect to I2P and Freenet. But its major privacy benefits are that it's the amnesic incognito live system. You boot from a flash drive, nothing ever hits disk, and when you shut down, it goes through and tries to zero out memory. What's awesome about these privacy enhancing technologies, and what I really love about them, is that they work on a trust but verify type mentality. When you use a VPN like PIA where they say, hey, we don't log, okay, that's cool, that's great. I believe that they don't, I trust that they don't, I believe that, sure, why not? I'll take them at their word for it. But is there any way for me to verify that they don't? Not really, right? That's just the way it is. But in the cases of TOR I2P, you can look at the source code, you can do your own analysis, and you can decide for yourself. You can do your own verification about how it works. And we'll talk more about that soon. Great thing about the TOR packages in Debian, Red Hat, etc., they come with packages for TOR already, and they usually include a glibc wrapper called Torify. This allows non-TOR enabled applications to use TOR. So you can run Netcat through TOR, you can run SSH through TOR, you can run Metasploit through TOR. You see where we're going? We have all the pieces now, right? The downside to it is it's not necessarily perfect. If you have a piece of software that generates its own raw packets to do DNS or to do socket connections, the glibc wrapper isn't going to be able to pick those up, and it's not going to be able to ensure that they go over the TOR network. Additionally, Torify doesn't have any configurable options. So when it receives a connection on the loopback device for something that's running with like a TOR connection, it thinks that's weird and it drops those packets, which is the right thing to do, unless you're trying to use it for hacking, in which case maybe you want those connections. So we are going to actually use proxy chains instead. It helps solve this problem. There's more information at torproject.org. It's a wonderful product. I'm sure, how many people use TOR, like regularly? I use it, yeah, like daily. So it's awesome, check it out. I2P is also really great, but they serve different needs. All right, so TOR, quick and dirty. This is like I think this is the slide that you'll have to always show people when you're talking TOR, because it just has the most information about it, or all the important information for most people. So the way TOR works is Alice wants to talk to Jane. Alice doesn't want Jane to know that Alice is the one talking to Jane, but Alice also doesn't want anybody else to know that Alice is talking to Jane. So Alice connects to the TOR network, talks to some directory authorities, gets some data about what the network looks like, and this includes private and public key pairs, or not private keys, I'm sorry, just the public keys, but the public part of private public key pairs for all of the hosts in the TOR network. Alice then chooses 3 of those hosts. They are called the guard node, the relay node, and the exit node. The exit node is the node that's going to actually communicate with Jane. The relay is going to communicate with the exit and the guard, and the guard node is going to communicate with Alice and the relay node. And the way that Alice ensures, verifies that the guard doesn't know who the exit is necessarily, and verifies that the relay doesn't know who Jane is by using strong technical controls, i.e. cryptography. So Alice will take her packet, her message to Jane, and will encrypt it using the public key of the exit node. That would be the last node in the bottom left-hand corner here, just before Jane. Encrypts that message. Hey, tell Jane I say hi. Encrypts that message with the public key of the exit node, and then takes that encrypted message and encrypts it with the public key of the relay node, the one in the middle on the far right. And then takes that entire encrypted message, building a ball, an onion, one might say, and encrypts it with the public key of the guard node, center node. And then Alice sends that entire message to the guard. The guard decrypts what it can using its private key, finding out, oh, I'm supposed to send this to the relay, and sends the remaining encrypted message to the relay. Relay does the same thing, and it unravels the onion until eventually Jane gets the message. And that's just that's the quick and dirty of it. All right, so remember our remote setup? We have our remote port forwarding. Awesome, simple, straightforward. Great, client connects, etc. Well, it connects through the internet. And it's really easy. We just switch the internet with Tor. You just like, whack, Tor right in the middle. Since Tor is just another network, works like the internet, it just has these strong anonymity protections. So you can build your SSH tunnel through the Tor network instead of through the regular internet and still be able to receive sessions over it. So let's do that. Now, originally when I had set this up, I set it up for a workshop at CactusCon. And I called them about 2 weeks beforehand. I said, hey, I just want to make sure you guys have internet, right? Because I've deployed infrastructure out in the Azure cloud, and we're going to need to have access to the Tor network because that's the basis of everything. It's the whole point. Like all the other stuff before this is just set up for this one moment. So you guys have internet so that these 100 people will be able to do this, right? And they said, no, we don't have internet. And I was like, I'm sorry, what? But like 2 weeks. You don't have internet? Or maybe 3 weeks. Okay, well, I'll think about it. So instead, I built my own Tor network, which is running on my laptop. So, and that's the thing that I turned on to start with. Since we're connecting to the Tor network, we're going to use a program called Proxy Chains. And I'm already connected to the Tor network, and I'll show you. Oh, I type things funny, apparently. So here's the Tor process running, and it's configured to connect to my Tor network as opposed to the real one because I don't actually have an internet connection for this machine right now or any of these machines. They're all internal. So we're going to use a program called Proxy Chains. You can just apt-get install Proxy Chains or apt install Proxy Chains. And the only thing that you really need to do to get it configured, it's great. It starts off and it defaults to use the Tor network. So you apt install Tor, you apt install Proxy Chains. It's already ready to use the Tor network. But Proxy Chains also thinks it's weird when it gets a packet on the loopback from a machine that shouldn't be getting packets in, and it goes, oh, you're getting hacked, so it drops those packets. So we go ahead and say, hey, we add this one line, local net 127.0.0.1, and we're going to take anything from anywhere, and that's okay. We're like, these incoming connections are all right. We expect to see them. If you don't do this, you won't be able to receive your sessions, and that sucks, and that bothered me for like probably a week. I was like, what is happening? And I just kept reading blog post after blog post after blog post and nobody's talking about this. Half the reason why I decided to put a talk together. So once you have it configured, and that's just that's the one magic sauce, you can run the exact same command. In fact, I'll run the exact same command with Proxy Chains at the start of it. This will wrap the remaining command to go through the Tor network. And you can see that it'll intercept your DNS requests and it'll send them over the Tor network and proxy them out. and then it'll establish the actual connection so that when and we can check it right here on the pivot box, we can see, hey, here's the pivot box. It's been connected to by a new host. This is one of the hosts in the Tor network. We don't know who they are or why they're here, but they're here and they're SSH'd in. Combining this knowledge, we can use proxy chains again on MSF console. And we're going to launch the exact same exploit that we launched last time. Hey, you run this payload, and when you run it, I want you to connect back to my pivoting box, if you'd be so kind. I'll set up my handlers just like last time. Same deal. An external handler, an internal handler, just like normal. Oh, even they think, hey, I forgot about this. Metasploit's like, hey, you're listening on a loopback. You know you can't like get traffic to that, right? It's not really meant for that. You probably meant to do something else. No, I didn't. It's okay. You're doing it right if you get the warning. So we set up everything just like we did last time. Set up everything just like we did last time. And interesting to note, I never noticed this before until I was actually doing this. The moment you set our host, you send out a DNS request. So if you even start doing recon on something, you might already be exposing yourself externally when you're using Metasploit. So if you were like, well, maybe start doing some recon here. I'm not going to use the Tor network right away. I'm not going to run proxy chains. And you set our host, you've just revealed that you have some intent to connect to that remote server, which could be bad for you eventually if somebody wants to at least dig in. I guess it depends on how much money gets lost. So now that the exploit's all set up, we run it again. There's a crap ton of TCP connections, DNS requests, all those things. And it's like, hold on while we do all of this. It sends the payload exactly the same way, and we get a connection back once more on our local host. And it tells us, hey, go clean up your session. You probably figured it out. The next slide's an analysis slide. Hey, go look at the stuff. So the blue team kicks on because they notice something weird's happening, or however they get alerted, and they log in, or they pull memory, or they do whatever, and they start looking, and they see, hey, our web server has connected out to some other box, maybe in our own network, on a weird port. That's abnormal. But now our incoming server is still the Tor network. So what we've built is we've built a layer of protection in front of us as the attacker that's just Tor. We always go through Tor. Everything comes through Tor. If you follow Greg Q, what's his thing, right? Use Signal, use Tor. Use Signal, use Tor. That's all I see on Twitter is use Signal, use Tor. And one day I was like, how do I use Signal and always use Tor? Like if I'm hacking something, how do I use Tor? So I spent the time, I figured it out. This is how you do it. This is a way to do it. And this matches up pretty well, I think, with what we see in APTs or whatever, just people hacking around on the internet. What we see is that they start off at their home connections, they connect to a VPN or an RDP server somewhere in some cloud. They use that to stage attacks where they then compromise a next host that they use to stage attacks. They usually get about 4 layers deep at minimum, and that's enough. And if you listen to the FBI talk yesterday, phenomenal, I thought. If you put enough of those servers in just 2 different countries, that's enough to tie up the investigation forever, effectively. But maybe it's not actually forever. I think if you use something like Tor, it can, in fact, be forever. So personally, if I got to choose, hey, am I going to use some VPN connection, connect to my RDP servers? No, probably not. I'm going to use Tor. I'm going to connect to my RDP servers that way and then move from there. Keep trying to Alt-Tab in a VM and it's not working. Derp. All right, so added slide in here for if there's any time left. It looks like we have maybe 10, right? Yeah, a few minutes. I don't know if that's enough time for me to set up the next one. So the idea would be, what if Tor was blocked? Just questions if anybody has any. So if Tor was blocked, what would you do? Right? Anybody just want to throw something out?
SoCat.
Sorry? Oh yeah, okay, cool. Yeah, that sounds great too. Yeah. I would use the pivot box. I would just set up a local for it to go out, and then oh, I like it. Yeah, that's good. Yeah, that's great. Any other ideas? Tor's blocked. How do you get to the web server? Or even, yeah, if the Tor network's blocked for you, it shouldn't be, because you should control your own network enough to at least connect. Anyways. Right. Yeah, yeah. I like that. SoCat for, yeah. Okay, I'll check that out. So some things I learned. Gray Raven said this the other day. DNS is always the issue. And it's always the issue. Like every problem I had while setting this up, I was like, man, why doesn't this work? Oh, it's DNS. Right. My DNS isn't working. Excuse me. I also learned that doing a workshop with like a live demo without internet, super hard. Turns out you gotta like do a whole bunch of stuff, and deploying your own Tor network. This is awesome. I think it's great. Like when you show up and you're like, hey, I brought my own Tor network. I'm gonna hack stuff with Tor. There is no like, I don't need internet. I brought the entire internet with me today. I think that's awesome, because you can put together a more realistic looking network. You know, you can see I'm connecting to an actual host, www enciphered. I'm using SSL. Those certs are actually valid. They're signed. All of that stuff. And you can connect to the Tor network and go through this thing with 100 people. That was at the workshop. And if anybody wants to do that later, like I said, I'll run you through it. Also, I learned that my friends are great. So my friend, Actual Reverend, he did a lot of the infrastructure when I was setting all this stuff up. I'm running 6 VMs on here right now to run everything. And he helped with the slides and lots of testing. So like all the GIFs, he loves the GIFs. My buddy Daniel, he set up Splunk and SSL optimization. So in the workshop, I was going through and showing what this would look like in Splunk, instead of just like, hey, look at the active connections. I figured it would just be faster to go through the active connections. My buddy James set up OSX. So I was hoping to push people in, or even show like, why would you not use a bind shell? Right? OSX sees the port changes for what's listening really quick. So if you hit a server that's running something like OSX or any HIDs, it's going to look at it and be like, hey, you're listening on a new port. That's weird. And that flags right away. But a lot of times people don't control their egress. They just say, well, we need to get updates. We need to get whatever. That's not a great mentality. It's one that I experience all of the time. I'm like, hey, you need to control your egress. You need to control your egress. And they're like, yeah, but we need updates. Cool, proxy servers. Something else. You need to have a grasp on what it's going to look like. And then other anonymous victims who, yeah, I just ask favors of everybody. Like, hey, write my slides for me. No, I'm just kidding. So yeah, any questions?